We're going to start with a quick review of the laws of exponents. So I'd like you to pause the video right now, copy down the first half of the equation I have here, then complete them to see how many of these laws you know. Hopefully you were able to come up with all 7 of these laws, as we will be using them frequently over the next few weeks. Again, this is one of those times that you're probably going to be thinking, why are we doing this? But when we start to do transformations to exponentials in the next couple of weeks, this is going to be really useful. So another quick review, right? We are going to be converting numbers to prime factors. So remember, prime is any number that only has itself and 1 as a factor. So our first prime is defined to be 2, 3, 5, 7. It's not all odd numbers. 9 is not a prime number because it can be rewritten as 3 times 3. 11 is a prime number, 13 is a prime number, and you can keep on going with the pattern from there. So when I am talking about writing something into prime factors, if we have something like 6, 6's prime factors are 2 times 3. If we have something like 24, 24 is 4 times 6. Our 4 can be rewritten as 2 times 2. Our 6 can be rewritten as 2 times 3. But then using exponential notation, this is 2 to the 3rd times 3. Okay, so we will want to be able to do that for these problems that we're going to work on next. So for our first problem, I would like you to rewrite the function g of x equals 6 times 4 to the x minus 18 by rewriting in prime factors and then using the laws of exponents to simplify. So our g of x is going to stay the same. Our 6 is going to change to 2 times 3. Our 4 can be rewritten as 2 squared. And our 18, we could write this as prime factors, but if you are adding or subtracting a constant, you can just leave that as is, because looking above, we don't have any laws of exponents that can be simplified from having addition or subtraction of like bases. So the next thing that I'm going to do here is I am going to rewrite this so that it says 3 times 2. I think it'll be more obvious in a minute. So that's really sort of staying the same. But then I want to use one of my laws of exponents to simplify this. So 2 raised to the second raised to the x. This is a power raised to a power. And the rule says that we multiply the exponents. So this is going to change to 2 to the 2x. And I'm going to keep that minus 18. So now I have multiplication and I have the same base. So my law of exponents says when I have the same base, I can add the exponents. So I'm going to put in an exponent of 1 just to remind myself. And now this becomes 3 times 2 to the 2x plus 1 minus 18. Okay, so again, this sort of falls into one of that category. Why are we doing this? We're going to see why we're doing this in the next couple of weeks, but this is sort of a base skill that we need to know. So we want to practice it a little bit. Our next one that I'd like you to try is converting h of x equals 12 times 4 to the x over 8 to the x plus 1. So at this point, I'd like you to pause the video, rewrite the 12, the 4, and the 8 in terms of prime factors. You're not going to have to rewrite the plus 1, okay, because again, that's being added or subtracted, and we don't have a law for exponents that for simplifying if we're adding and subtracting like bases. So again, at this point, pause the video, rewrite the 12, the 4, and the 8, and then unpause when you're done. So our 12 is 3 times 4, but 4 can be rewritten as 2 squared. Again, here the 4 was rewritten as 2 squared, the 8 was rewritten as 2 cubed. So again, I'm going to keep the 3 times 2 squared. I'm going to rewrite this as power to a power. I multiply those, so I'm going to have 2 to the 2x in the numerator and 2 to the 3x in the denominator, plus 1. And on my next line, now when I have a quotient with the same base, I can subtract the exponents. So the 3 and the 2 to the second are staying the same, but 2 to the 2x over 2 to the 3x, we keep the same base, but we subtract their exponents. So 2x minus 3x is negative x, and we're keeping that plus 1. Okay, and lastly, the 3 is going to stay the same. We have 2 to the second and 2 to the negative x. When we're multiplying the same base, we add those exponents. So this is going to change to 2 to the negative x plus 2 plus 1. Okay, so now looking at this, I have all prime bases in my product. I have each base only appears once, so that's how I can sort of tell that I'm done simplifying. And again, I don't have a rule that allows me to do anything with bases that are added or subtracted, so that's why that 1 can stay out there. This can be challenging for students. Try the practice problems. If you are really struggling with it, we can go over it the next time we're in class.